Hi, I'm Damien Toomey from Toomey Earthmovers, and this is what we build.
Welcome back to the Design, Creativity and Technology channel. My name's Aaron.
And what we have here is a tractor-drawn scraper. So we build these all in-house, control as much of the process as we can, but essentially what they do is they move dirt. So they're used to level, to move dirt from one place to another. The benefit of these over the likes of your self-propelled caterpillar scrapers, number one is the cost. This in combination with a big articulated tractor is significantly cheaper. Weight, they're generally lighter, so for certain applications where you don't want to have that high ground pressure, then they work well in those applications. They're good at grading. They have fine control over the contours of the ground that's left after they travel over it. And they carry quite a decent amount of dirt too. So similar in size to your scrapers. The one downside, I suppose, being lighter is they're not quite as good at compacting if building like a dam or something like that. But with the right methods and practices, it can be done with. In order to guarantee the quality of our workmanship, we press all our plates in-house. We got let down by some other suppliers, both lead times and price and quality, so we decided to invest in a press of our own. And so this is what we got, and we've had this for a couple of years now. We've got a couple of really good operators who really know how to use it, and they can be bending 12mm strength 700 plate and can achieve millimeter accuracy, which makes a massive difference when it comes to fabricating. We were fighting 5 and 10 millimeter discrepancies from our previous supplier, and they're having to dog and wedge everything together, and it just wasn't that nice. We're trying to fill little gaps that weren't shouldn't be there. So our guys can get the parts pretty good with this, and it makes a massive difference in fab time. And not only that, if they do happen to make a blue, then the fab guys can bring their part back and give them a bit of curry about it, and they can fix it right here and there and give it back to them, and off they go, trundle back over and weld it all up. So we've got 3 machines. We've got the 2 brake presses. So we've got 630 tonne, which is 6.2 metre long. It's about 5 metre between the frames. And then we've got a smaller 250 tonne press, which has got an assortment of dies there that we can put different radiuses in. Knife edge, 2.5mm, 5, 10, 15, 20. And we use them for a range of different parts. And we also invested in a little horizontal press, which is predominantly for outside work, based on the requirements of what we had and what we were trying to achieve in the big press. We machined up a bunch of dies for it, different punches and width V's, and we were able to achieve a similar result, and even a better result than what we could do in the big girl, far quicker on a much cheaper machine. So yeah, that was a great investment, that one. Here we have hydraulic cylinders for the scrapers. It's been a bit of a long and twisty road with cylinders. We've outsourced cylinders from a couple of different companies. We did make all the cylinders in-house some time ago, and then we've come full circle back to making everything in-house again. So part of the cylinders on our scrapers, we actually run a bush and a seal in them, and it's a more recent development that we've started doing to try and combat the pins seizing in the spherical bearings that we used to run. So for many years we ran an SKF GE Teflon bearing, so a maintenance-free spherical bearing, and they work really well, and they'll last years. But the problem come about when someone wants to go and remove a cylinder, and they try and tap that pin out. She doesn't want to budge, so you end up having to lance the pins out. So After a fair bit of complaining about that, we've shifted over to these bushes, which is the same bush we use in the main pivots. As you can see on these cylinders here, I'll just wipe some of this dust off. The end of our barrels are all one piece, so that's also another recent addition. We used to fabricate the end plate onto the end cap of the barrel, so with the addition of an old Integrex, we're able to do this all in one piece now, and so that just saves fabrication, and it ends up resulting in a nicer cylinder. And same on the rod end clevers here. That's all done one piece in the machine, and there's a special tapered fit with a thread retainer inside that, and that gets heated up and shrunk on, and that avoids welding here. That just neatens that joint up, and it allows them to go together quicker. Alright, we're just standing here in front of our old Integrex. So I bought this machine specifically for making the hydraulic cylinder parts. So she turned up as a non-runner, so had to strip it down, basically down to nothing pretty much, and rebuild it all. All the hydraulics were rooted on it. Must have got water in the oil or something. All the valves were stuck. Got it running, and it's been running for over 12 months making parts now. It's a real nice old machine, this one. It is rigid. Like it can take some big cuts, and so it's a really early one. So these early ones actually have the two pockets. So there's a KM63 taper there, which is for the turning tools, so they stay stationary, and then there's a Cat 40 pocket under there. So when it does its tool change, if it's going from a turning tool to a live tool, it'll pull the tool out, and then the head will drop or raise, and then it tool changes for its opposite tool, and then that's the live tool there. So that is 6,000 RPM spindle on that, and the head can obviously rotate, so it's got a vertical position or a horizontal position, and this machine also has a Y-axis, so it's plus or minus 90 mil, which is basically the requirement on why I bought this thing. It needed the Y-axis to make those hydraulic cylinder parts. Currently the machine needs a little bit of love. Gave a bit of a bump, so I need to get the spindle line back up again. That's why it's got this test piece in here, so a repair guy can come in the new year and just align that main spindle back up, get that cut and true again. Apart from that, this thing makes chips. It fills bins real quick. With these CNMG insert, we can run 4-5 mil depth of cut, 0.45 feed, 210. It just, the poor window doesn't stand a chance. She just gets a hammering. But it'll fill a bin in a day. Behind us over here is our little super quick turn 10 MS. So this is a live tool twin spindle machine. So it's got a main and a sub. We make anything up to 4.5 inch pistons and glands for cylinders in this machine, and they can do it one and done. So the machine gets its raw piece of material put in the first chuck, and we generally run a 3-jaw chuck when we do them. It's currently got the collet chuck on the main spindle, and it's all live tool, but no Y-axis on it. And so it'll do a second op on the sub spindle, and basically you put one piece of material in, you close the door, push the green button, and when the light flashes, you've got a finished part. So it's a great little machine, this one. In front of us here is some raw material that's destined to go into the lathes to get some turning done on them. We run off a work order system, so all the guys will get a work order for the job they got to do. It'll give them quantities and some details on it, and some program information, and then obviously the important part, the drawing, what they're actually making. So most of our stuff is repeat. So we'll have programs for it. They'll have jaws, so they basically just get the material, they put the program in the machine, set the jaws up, set the tools up, and run it. So here's there's pistons for 6-inch cylinders there. There's glands, these bearing retainers, some more bosses over there, and they're all destined to go in this rather ugly looking machine. So this was a more recent purchase, this one. We actually had a sister machine to that one sitting here up until a couple of months ago, similar size, but our bottleneck was the big lathes. So this thing happened to pop up for sale in Gladstone, which is a couple of hours north. So sight unseen, we ordered it and bought it off them, got it sent down on a truck. It's an ugly looking thing, but it actually cuts really nice. So we gave it a bit of a scrub. It was filthy. I think they've done a lot of cast iron, and being in that part of the world, they have a lot of metal dust in the air, which just, likes to wreck machines as well. So we gave it a scrub. It's got a 12-inch chuck on it, exact same as the Integrex and the Super Quick Turn 30. So all our jaws interchange between 3 machines. Live tooling as well. So it's a capable little machine, and yeah, it's a good little buy, this one. Makes good parts, and so that's a 28. So then our 30 is near identical size, except it's longer. So it's the 28 and the Integrex are both 1 meter Z, whereas this is 1500. So this has got the longer Z travel, which we needed for doing the barrels. So all our long cylinders, apron, bowl cylinders are all done on this machine. So it's also a good machine. As you can tell, we like our Mazaks. So predominantly the live tool lathes, apart from the Integrex, are all Mazatrol. So this machine we can't do ISO, it doesn't have the option. Neither does the 28, but the 10 does. But Mazatrol is so nice and easy for turning, and without the Y-axis on them, you're quite limited to your tool paths anyway. So the milling function in Mazatrol does the job just fine. So what we've got here is we've got 2 horizontal milling machines. This is a 500mm Mazak FH5800. So this is our newest machine. It's got the Windows-based software on it, the Fusion control. This machine is basically set up for aluminium. You don't do a ton of it, but it becomes a pain trying to clean out the machine when you swap materials. So 12,000 RPM spindle, through spindle coolant, all that sort of stuff. Twin pallet, so 2 tombstones, the 1 degree positional table on it, so not a full fourth. But yeah, it's a fast machine, this one. 50 metre a minute rapids, it can fairly move. So our other horizontal is our 400mm FH480. So 12,000 RPM spindle, 400mm pallet, twin pallet as well. 2-speed gearbox in this thing, so it can handle a big tap and a big cutter. And this thing it's like the Integrex of horizontals. This thing is rigid. It's actually more rigid than the 5800, and which is why we've sort of kept it for steel instead of making that one aluminium. But yeah, 52mm high feed cutters, it'll fairly rip off the material pretty quick. And this is any part that needs sort of more positions than just 180 degrees, like op 1 and op 2 in one of the verticals, which is what we use this for. Some of our parts have grease galleries on the end, so we'll do 0 degrees, 180 degrees, and then 90 to drill and tap grease galleries in the parts. So that's what we'll use this machine for. Or if we have a big batch of smaller parts, we can load them up on each side of the tombstone, and it can attack all those parts at once. benefit of the twin pallet being you can replace the parts on the exposed pallet while it's still machining, so less downtime, it can just keep running. So this FJV 3560 we brought from Japan. So it was in a pretty ordinary state when we got it. It was missing the main big operator panel where that clear panel is there and the handle. So that was missing, that big holes cut out of it. It had been running plastic, so it had a massive big vacuum table on it. And it had been running plastic, so the whole machine was just full of plastic everywhere. That 2 44-gallon drums of plastic we dug out of this thing. And so with the parts books, I scaled the diagrams and measured the machine and drew up a brand new cover for it. So we pressed it all up in-house, fabricated it, sent it down to our painters to touch it all up and make it look like it's worth as much as it cost us. So it's this is a replacement for our old big vertical, which has now found a new home. And this was to replace that. It's a newer machine than what that one was. It's the same control as our other little vertical, and also the 400mm horizontal. So the programs will all be interchangeable. It's a 50 taper machine, as our old machine was. Similar work envelope, albeit this one's fully enclosed. So our other one was exposed, so it would make a horrible mess. Coolant and metal chips all over the floor. It was a daily battle to sweep and vacuum up the mess that machine made. So it's a twin column machine, a very, very rigid machine. It's got 10,000 RPM 2-speed spindle in it. Unfortunately, it doesn't have through spindle coolant. That was one of our requirements when we were looking at buying a machine, and the seller told us it had it. So turned up and turns out it doesn't have it. So we will look at adding that. It was an option, and we can buy some parts from Mazak to swap it over. Just not something we'll just be doing right now, but that is a plan. It also came without a chip conveyor, so I scrounged that chip conveyor from another scrap machine. So we modified that, drew up all the panels in the tank, and also got it painted. And so now we have a chip conveyor. Our little vertical also was without a chip conveyor, and we end up fitting one ourselves, and that come from the same company where I scrounged the other conveyor from. So this is a travelling column machine. So it's had a hard life, this one, but it still makes good parts. So the table stays still on this one, so it's fixed, and the head moves in the X, Y, and Z axes. And so it's not a terribly rigid machine compared to our other ones here. We love our rigid machines, but it can still work hard and remove quite a lot of material, so we just have to treat it differently to the other machines. Just find its limit and try and stay within it. So I'm Damien Toomey, this is Toomey Earthmovers, and thank you for watching.